All right. Looks like we got sound to OBS. Sort of in the middle there, not quite. Let's do that. Put Twitch over here so I can see the Twitch chat. Pause. This preview, is this running? Yeah, let's pause this. That many previews. Okay. Jumping straight in, I'm basically picking up where I left off a few nights ago, working on this TileGrid inflator, which at the time I was calling bitmap inflator. I'm wondering now, though, if it makes sense, or I should say I'm thinking it does make sense that we probably call this TileGrid inflator. TileGrid inflator, since the thing you get from it is a tile grid, not a bitmap. And especially since we are gonna be changing it to basically where you declare the size in tiles rather than pixels. There's less like individual control over the exact size. It won't be allowed to be every possible size, only multiples of the tile size. Uh-oh. Might have had a here to reload. We might have had a bit of a network hiccup there, maybe. I assume I probably cut out for a minute. Hopefully everything is coming back all right. Let me make sure this is still showing here. Yeah. Okay. Oh, we're looking good still there. We're looking good again. I think it probably went out for a second. Alright, so let me put the chat back. So I'll throw this chat as well over here so I can... There. Nobody just says anything. Alright. Pull a couple of these and then we're jumping in. So I think TileGrid inflator, continuing where I left off probably before I started spacing out here, I think TileGrid inflator might be a better name for this because the thing we're getting is a tile grid, and I think this helps to imply the fact that we're going to be more strictly tied to the size of the tile, multiples of the tile size, whereas originally my first attempt at this was more like you could make it any size you want. It didn't really matter because it was going to use basically 1 by 1 as the tile size, so it would be able to put any number of pixels in. So I think I'll also change this. Inflate tile grid. Oh, we found, okay, yeah, we found uses. Do refactor, yeah. This changed it in both places, which is nice. And then, now that's the easy part. So next we gotta actually change the way this works. So these are not pixels. And actually, I think maybe I'm gonna change up the idea of declaring pixels, or what we were about to move to as tiles. I think I might just make the rule the tiles are 1/3 the size of the sprite sheet, and then the repeatable tile is the middle one. So for folks that didn't watch the first one of these streams, which I just kind of jumped into the middle of where I left off before. So if you didn't see the previous stream, some of this stuff probably doesn't make sense. I can fill in a little bit of the gaps. We're basically, we have sprite sheets like this thing. We have sprite sheets like this, and we're trying to make a bit of CircuitPython code that will take this small sprite sheet and then be able to expand it to whatever size we want by duplicating the middle pixels, basically. So it'll be able to get bigger horizontally and vertically. And originally I was trying to say, like, you could declare the stretch zone, basically. You could declare the zone that is allowed to repeat in order to grow in size. I think instead, though, I like the idea of just, of the tile size being 1/3 of the sprite sheet, and then the middle tiles horizontally and vertically are the tiles that can be duplicated. And then we just leave it at that. And you can always use a bigger or smaller sprite sheet based on your needs. Essentially, your needs being how much detail you have in the corners, I think is probably the biggest driving factor. So if you're trying to achieve a rounded rectangle like this, then it's kind of like your corner radius determines your sprite sheet size dependency. But depending on what, whether or not you're doing actually rounded rectangles or other arbitrary stuff, you may or may not care. But I do think the middle tile is a pretty reasonable default and will allow us to do all of the same sorts of stuff as I was thinking, and it will make the API simpler because the user won't have to declare it. If we really want to, we could go back after the fact and enhance it by making it declarable. It probably won't be too hard to change after the fact if somebody does come up with a need for it. So we're going to say, in order to inflate, we just need to give it the bitmap path and the target size, and I think that's it. The target size is going to be in tiles. So they're going to say something like bigger than 3x3, because 3x3 essentially is the size of the sprite sheet. So, 3x4 or 4x3 or bigger. And then we're going to generate a new tile grid multiplying the center rows and columns enough times to get to the target size. So if they say, 8x8, then we're going to duplicate the center row and columns, or really, I guess you could think about it as the 4 sides, really. Side 1, side 2, side 3, side 4. We're going to duplicate all of those 7 times, so we end up with 8 total. And we're going to fill in the middle with the middle tile. Does that actually work on this one? So this is 48. That's 16, I think. Third of 48. Oh yeah, that seems fine. What about, we were over 1, 16. Down 1, 16? Are we all white? Yeah. That should be fine. Yeah. That'll do what we want. Okay. We're going to assume a third there. We're going to get the target size in tiles. I think that might be the only thing we need if we do it this way. So then we're going to load the bitmap, and from the bitmap, we're going to say tile width. I guess we could support rectangular tiles. I'm thinking of using it with squares, but we could maybe support rectangulars by doing these separately. Tile width equals image.width over 3. One thing is you do need to provide an image that has a size that is multiple by 3. That would be one thing we definitely need to document, is since we're assuming 3x3 is the sprite sheet, your thing has to divide by 3 or else it'll break. I don't know to what degree it'll break. If it'll just look weird or if it will actually crash. Write somewhere the code to find that out, I think. We can separate these, and then target width, target height. Yeah, so that will get those out of the tuple that came to us. Okay, so we're already creating a tile grid here. I'm gonna go ahead and just overwrite this previous attempt. So target height, target width will be in tiles, which I believe is correct. I think TileGrid takes those in tiles. Oh, I never did set the focus. I don't have anything to show yet, but I noticed the focus is all whack. Let me fix that up at least a little bit. Probably fine for now. Let me pull up the docs, CircuitPython. I think, is there a docs link here? Yeah. TileGrid. Oh, I should use this thing. Oh, I don't have it bookmarked here, actually. That's bookmark that thing. Leo. TileGrid. I find it tough to get the right thing sometimes. There it is, okay. Actually say. Okay. Should add, I wonder if they're like malformed or if they just don't exist. We should add the right spot. Yeah, I think so. Should add parameter docstrings for this. Probably handle that. Pretty sure the way this works though is the height and width are in tiles, and then the tile width and height are in pixels. I'm pretty sure that's the way this works. So we have target height and target width in tiles or whatever we passed it in. It's probably in pixels in the current test code, but we'll change it to be in tiles. And then tile width and tile height. Maybe a couple of these down here. Let's do tile size on the same line. Tile grid size on the same line. These ones will be tile width, tile height. Oh, you know what? I just realized I left the sharpening thing. How's it going, Tammy? Would you also want to support there being more than one center tile? So duplicate ABC, BC, BCD. The sprite sheet width is 4 times the tile width. I think that would be nice functionality to have ultimately, but I think I want to target just the 3, just the 1/3 to start with. But I do think because we're supporting different height and width, I do think you could actually achieve the same thing that you laid out just by having a larger sprite sheet. CD, BC, oh no, BC, BC, BCD. So basically you're saying it would be 4 tiles wide and you would repeat the center 2. Yeah, never mind. I guess there would be, I think there would be things that you wouldn't be able to make the exact same. You could get similar, but your corners might be small and weird looking. Yeah, I think ultimately I'll want to support that, where you'll be able to declare. Maybe we'll have an extra optional parameter that lets you declare the like duplication zone, and then you can set it. By default, it's 1, 1, which is the center tile, but you could set it to something else. Well, it would have to take lists or tuples or something. So you'd tell it, you know, indexes 1 and 2 for the horizontal duplication. Does that change the possible sizes too? That changes the possible target sizes as well. So it'll have to have the math to enforce that. That is kind of how the original thing that I'm basing this idea from works. It does work more like how you mentioned, and even to a more customizable degree. The original thing this is really based on is these things from Android 9 patch, PNG. These things are used by Android applications, or they can be. And you declare with pixels. The pixels that you color in black on the top and the left, that represents the zone that is allowed to be duplicated, the zone that is allowed to stretch. And then the pixels on the right and the bottom have a different meaning as well. But I'm mostly focused on the ones that declare the growing zone. And this is actually more similar to how I tried to do it originally, which was like we could grow to any size. even if it wasn't a multiple of our tile size, which would also help fit the idea of the 4x1 or 4x2, how you're thinking, or 4x3 as well. And I'd love to eventually support this as well, but it will definitely take some more work to actually like parse out the black pixels and to provide. Basically, we'd have to define rules about like what does it do if it only needs partial sizes. Since we don't have the ability to like arbitrarily scale it, we have to kind of decide how it's going to fill in pixels. All right, so we create a new tile grid. Our range, this was debugging. This was my attempts at debugging, I think. We don't really need to do this. I'll come back and erase it later. What we do need to do is fill in. Okay, we need to fill in the tiles, which I guess is what this was doing, but this is not how we're going to do it. Instead, we're actually going to do it almost the same way that it's done on this Learn Guide page where we started from as well. We're going to do the 4 corners, and then we're just going to start duplicating the sides all the way across and all the way up and down. And then we're going to duplicate the middle everywhere, as big as it needs to be to fill in. Whoops. I think this code is basically going to be the same as what's here for this castle. This is also a very similar concept to what I'm trying to do. Basically build a helper function that will create these larger panels for you out of just the 3x3 sprite sheet. And I think, yeah, this code is down here. Okay, so they place the corners one at a time. Seems reasonable. Ours is not castle, but TileGrid. We won't be able to hard code the edges like this, but we can always just say width -1, TileGrid width -1. Whoop. And so this one, the numbers will be different because there are characters in the sprite sheet as well. So our top left will actually just be 0. Our top right would be 0, 1, 2. Our lower left would be 0, 1, 2, 3, 4, 5, 6. This would again be TileGrid. Nope, TileGrid dot width -1. Gonna need to do something very similar when I get to the display or rendering part of the card deck library. Oh yeah, to create the if you could have a smaller sprite sheet with the edges of the card, and then you could fill it into whatever size you want on the screen. Hopefully, my intention is to make this thing somewhat reusable. So if it's done by then, you may be able to utilize it to some degree. Which would make sense too for playing cards. You definitely would want to end up as a rectangle. Although I think this will be able to be a rectangle. Yeah, I think this will still be able to. Because you'll pass it the target size. It'll just be rectangular. Yeah. You could do like 4x3 or 5x4. Eventually, we'll also put a transparency pixel, and then you could make even weirder sized things by having the outside edges of your sprite sheet be transparency. Then it'll make it more narrow. You won't be stuck as rigidly to the tile size. I mean, you still will be, but it won't visually look like it. So this is lower right. So this is going to be tile. Oh, you know what? I think well, okay, so the first one should be width. This one should be height, though. Yeah, height, lower left. And then this one should be both. Tile, grid, width. Ooh, what is all of that? This one. Grid, height, -1. And not 11 will be 9? 8? I think it'd be 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. So there's our corners. Now we can do all 4 walls. Although we might as well do the side walls at the same time and the top and bottom walls at the same time. So I'm just going to use I for now. Maybe I'll change this to X or something. I'm going to do X. Yeah, let's do X. For X in range. Range is going to be interesting. We are going to be 1 less than the target. No, 2 less than the target size. Target size, and specifically the target size width. -2. So we ask for a target size of 5. Our loop needs to run 3 times. 5 minus 2 is 3. And range 3 will run 3 times, I think, right? I think it will. Range 3. Oh. For I in range 3. And I. Yeah. Okay. This definitely runs 3 times. So, do that. We go TileGrid X, and then no. Yes. Yeah. X and then 0 equals tile index 1, this tile, top center, index 1, and then we can also do the bottom at the same time. No, don't want to do any of that stuff. Alright. Got the old Twitch bot seller things. TileGrid height. Oop. This one. So top row, bottom row. And except instead of X, we're going to do X plus 1 because we want to skip the first column, which is going to be the corners and the left and right edge, which we're going to do next. Plus 1. So it'll do index 1 through index 3 in our example. Index 4 is the last one if we did ask for 5, so that sounds right. For Y in range, target size 1. For Y -2 again, same thing. We're cutting out the corners, they're already done. This is going to be pretty similar. But hard code the 0 there. Y plus 1 here. This is which one? Oh, these 2 tiles are different actually. The top row is tile index 1. The bottom row is tile index. So what was it? 0, 1, 2, 3, 4, 5, 6, 7. 7. Now we'll do the left edge, which is 0, 1, 2, 3. The right edge, which is TileGrid.width. Why is that the thing that is saved in there? I guess that's actually not... I guess that is kind of close to what I want, isn't it? Kind of close, but not quite. It's weird that it's such a long thing. Usually it doesn't fill in more than one part of the expression. It had a comma in like the next value, which is a bit more than I am used to it guessing. The right edge, and then y plus 1, and this will be 0, 1, 2, 3, 4, 5. Okay, so we've done the 4 corners. We have done the 4 edges, top and bottom, and then left and right. Now we need to do the center area. So I think we'll go for X in... Actually, I like doing rows as my outer loop, so I'm going to do for Y. And I think this is actually just the same, right? Target width, no, target size, Y, so we're going to do height. And then in here, do the actual row. Whoa, what am I doing? Target size, 0. X plus 1. Y plus 1. Oh, and we need to subtract -2 because we have all of the edges done. 2 edges on each direction. And then we go to tile 1, 2, no, 0, 1, 2, 3, 4. Tile 4. Okay. That seems like all we want. We will probably have to fix this a bit. So first of all, which one was BMP 0? I took a attempt at one of these. $47. So we want to use the 48 one, I think. Where's I saving these? Should probably end up renaming that folder as well. Bitmap 1, I think, is... Go. Map 1 is the 48 pixel one, which divides by 3, so that's the one we want to use. No more of this. And then size, yeah, 12 and 6, that seems like an alright target size. This was all me not understanding what I was doing at the time. Not believing reality. But in reality, I just was setting it to not do anything. And then looking for something to have happened. Yeah, that should be all we need. Port error, bitmap inflator, right. So this changed. I'm surprised that didn't really find it and change it for me. Interesting. It changed the name of the function, but not the... Did I not change the name of the file? No, I changed the name of the file. Interesting. Pretty good usually about finding when stuff changes like that. No module? Why don't we use TO here? It's not going to be TTI1 though. Module. Inflator? Did I spell it wrong? Inflator, yeah. Actually, I don't know which one's right and which one's wrong, but they're different, which makes them wrong. There we go. All right, and one thing I found actually when I was streaming this the other day is the screen does get washed out a bit. Maybe if I get really far in there, and I think the light will help a little bit. Probably probably make a different one of these that's not quite so bright. Maybe we shouldn't use white as the inside, that would probably help. But it seems like this worked. I don't know how well. Oh, actually, yeah, that's quite a bit better. I was gonna say, I don't know how well I can focus it. But that's quite a bit better. So we should also now be able to just change the size. If the true magic in this is that now that we have this, we can just say whatever size we want. I want 6 by 16, tall and narrow. Boom, got it. We can do any size as long as it's bigger than 3. Has to be, I think, 3 or bigger. Since our original... I don't know what it would do, actually. Probably will break something. Didn't break anything. We can do 2. Really, we can't do 1, though, right? Huh, we can do 1, but you only get the bottom row. Which is actually kind of interesting. You only get the bottom row. Huh, I may end up using that functionality, actually. Because part of the motivation for this was I wanted to be able to make this thing that could inflate these shapes for me. And ultimately, I want to be able to support layout. The 2 use cases, the 2 specific use cases I definitely wanted to make sure to support were... What's like a panel? I must have searched something different the other day. Yeah, these are all way different. Here's one of them, though. Or like this. These are the more common ones these days, but these are like the original old school tab layout type things. I want to be able to support something like this as well as something like this where it's just the underscore as the visual. Because ultimately this is going, the main reason I'm doing this right now is for the tab layout. It has lots of other uses, but too tired to do math in your head right now, but that's what my brain asks when you did that. Oh, let me see. If you do smaller than 3, your range loops, what are they going to do? It's a good question. I guess they go negative. I don't actually know. What they are doing specifically. We've seen the output now, but it is actually an interesting question. So it would be... So our target size was 1 for Y. We got -2 and went down to -1. I don't know, does it knows to loop by negatives, I guess? I'm actually sure what it does. For I in range -1. Print I. Oh, it doesn't loop at all. Interesting. So then this one would not have run. Makes sense because we had no sidewalls. This one would have run, but this would have been 0. Okay, it's slowly starting to make sense in my head why it worked. Why it worked the way it did, at least. Because what we ended up with was basically the bottom row of our sprite sheet stretched. Oh, I went back. Whoops. Yeah. So we should probably make it, if we want to support this single row type of thing here, we should probably make it so that you can actually make it only the top row if you want only the top row, or only the middle row if you want only the middle row. It kind of goes together with being able to declare which ones are multiply zone. So range of a negative number is no up. Yeah, seems like it. I know you, I mean, you can do like, you can give it another argument. You can do something like for I in range negative, you could say -1, and then you could say count by -1. This time it, I think, should print at least once, but maybe only once. Oh no, it didn't. Oh no, no, no. Okay, so it's, I did it wrong. It's, so it would actually be 0, and then -1, and then count by -1. Oops. Then it should actually print once. Yeah. It counts 0, and then it goes down to -1, and it's already there. So you can, like, make it count backwards if you want. But yeah, what it does specifically when you give it just -1 is kind of arbitrary. Is it any negative number? What does it do, like... What does it do like this? Anything different? Oop. No. Okay. Any negative number will make it not loop at all, unless you also tell it to start at 0 or somewhere, and tell it to count down. Yeah. Interesting. I wouldn't have been surprised if they had a shortcut where, like, if you just give it a negative number, it assumes that you want to start on 0 and count down by 1. I could see that being a fairly safe assumption for the majority of people who try that. Okay. So this is working pretty good. This is really what I wanted. So let's think about, well, okay, first of all, let's clean it up. Let's get rid of all this stuff. We don't need any of it anymore. Really need this either. Honestly, we could probably get by without even having print. End up using this. Although maybe we'll want this. Maybe we'll want this when we are allowing them to declare the region. We'll see. Keep this for now. I suppose I could. I'll keep print for now as well, I suppose, because we might need to troubleshoot once we're doing that. What does 2 do then? 2 would just give you no top, essentially. So size 2 would do, or no one side, I guess, whether it's top or bottom. Oh. Oh. Oh, right, okay. 2 gives you the top row and the bottom row. That makes sense. I think I tested that also. Nice. Okay. You do it by 6. So if we start thinking about the idea of declaring multiple tiles for the duplication zone, the corner logic stays the same. Top row and the bottom row changes to basically, I guess we probably would go in multiples of the duplication zone size. So if they have a 2x1 duplication zone, 2 width and 1 height, well, like 3 height. Center. So you'd have to provide, your sprite sheet would have to be different as well. So maybe we could just make it say no matter how big your sprite sheet is in tiles, the outside 4 corners are always the tiles that do not duplicate. We could just say any tiles except for the outside 4 corners will duplicate. And so if you had a 4x3 instead of a 3x3, then the inner 2 tiles on the sides with 4 would be part that duplicates. You have to work out the way the logic would change here. I think basically I would want to come up with a way to write these loops so that it works no matter what size the duplication zone is. So I'd have to really think more about the logic of how it works with the multiples. I'm inclined to say that we would basically divide this number by the duplication zone size in that orientation. So we'd be looping like half as many times if we were trying to make a 2 wide. But for each iteration in the loop, we would set 2 tiles. We would set the 2 duplication tiles at the current index, and then the next iteration in the loop, we would scoot over by 2 and set the next 2, and the next iteration we'd scoot by 2 and set the next 2. Although, how do we know the tile size, I guess? We're assuming the tile size here because we divided by 3. So if we gave it a 4x3 instead of a 3x3, it would need to know the tile size. We'd have to tell it the tile size separately. Because it would need to know that it's, in this case, still 16 by 16. So maybe we should have tile size and default it to none, and then if tile size is none, do these, else tile width equals tile size 0. Oops. Seems like the most intuitive behavior to me. If you want to give it a sprite sheet that's not 3x3, you should specify the tile size. Yeah. Tile size default to the width and height. Yep. I think so. Do we have a way to know the dimension in pixels of the sprite sheet? We do. After we inflate it right here, image will be a bitmap object, and bitmap objects have width and height, and it will be in pixels the size of whatever image we pass. In our case, that will be the sprite sheet. I do want to do transparency pixels. Transparent index equals none. Then basically something like, if we want to be fancy, we could even allow multiple. Yeah, let's do that. Just in case. In the 99% of the time, if I was using this, I would only want a single color to be made transparent, but maybe somebody will have a reason why they want to do multiple colors, and it's not that much extra work, I don't think. So if transparent index is not none, palette dot make transparent. Well, okay, so if it's not none, so we could basically check it, type transparent index tuple. How do you check for a type? Type tuple. Tuple is true. Okay, good enough. So if type of this is tuple, then we just loop them for index in transparent index elif type int transparent index. Okay, so that then you could pass it a tuple with multiples or just a single int. So then instead of defaulting the number of tiles to none, should you default it to I think we have to default it to none because we don't have the image size until we're inside the function. So the first line in the function is what loads the image, and I don't think we have a way to access the size before we do that, so we can't use it up here. I think, at least. Okay. So let's, what does this look like if we make our pink transparent? Actually was the way I had initially imagined this one. I think 0 should be pink index. Yeah. So let's say here, transparent index 0. Yeah, so now we cut out the background, which this allows us to have actual like curved edges. Let's make another one of these. I'll start with just, how do I want to do this? I'm going to start with making the inside darker. Probably good. Oh, let's go image mode back to here. Fill. Let's go one bigger. Or one. Bigger. That feels like two, but all right. We do feather. It's much more or less like what we had before. Oh, I see. That's because sometimes I wish fill bucket was like not caring about the colors and just filling the entire selected zone. Oftentimes I use gradient like this to fill the entire selected zone. Actually, while we're here, let's go... Well, I need to change it back to indexed for one thing. Let's go... Select all the blue. All the blue. Ones too. And then... You... That. Back to... Indexed. Vert. Make sure pink is still number 0. Yep. Now, 2. The corners got kind of sharp on the inside. It's alright though. Mainly I want to just test that I can make 2 of these at different sizes and that everything will work. So we got one that's tall and narrow. Let's make one kind of like 4x3-ish. Maybe like 12x10. It's not really 4x3, but a bigger rectangle. Do transparency the same. Whoa. Just say something like, put it out to, I don't know, 180 or something. The object isn't subscriptable. Oops. That one's a tuple. Nice. So actually, I felt like the inside corners got a little bit sharper, but by the time they're on this screen, I don't really see the spikies, truthfully. I guess I was zoomed way in, wasn't I? This is like, oh yeah, 1600%. I guess that's a little bit exaggerated. Looks pretty good on here. So, okay, so now let's say if I wanted rounded corners on the top, but square corners on the bottom, which was one of my original requirements for this idea. So let's say if I was going to convert this one to be square on the bottom, what I would do is... I mean, really, it would be better to just regenerate it instead of doing it this way, but I'm going to do it this way. Basically do this. Move this down. And then put in, well, I'll grab one from this side. I don't know how tall that was. 4 by 23. Oh. Nope, that's wrong. 3 by 10. Wait, what? Not copy? Copy. There we go. Was having the wrong layer highlighted, so it wasn't actually copying anything. Then basically, whoops. This one. Oh, gonna do that again. Actually, you know what I want is... I don't even want a bottom edge. I don't even want a bottom edge. Yeah. I want this to, yeah, I want this to just run down. No bottom edge. So, should have made that bigger. What I can do, let's just make another one for now. Before we go any farther, we're gonna just smash all of this. Just, yeah, flatten. And now, basically take this. Okay. Now this will be 3. And let me scoot this one up some. Let's put our new one at the very bottom edge, and let's start giving them tab label. So I want to go. Let's look at 2 height. By 2. Let's do that. Then tab label dot x. Let's just go. I don't know. Matter too much. A little bit in. Label y. This one I want it to go to the bottom edge. So y equals display height minus tab label dot tile height times tab label dot height. Height is in tiles, and then tile height is in pixels. So we multiply to get the actual size in pixels. We subtract that from the height. That should leave us at the bottom. Oops. Nice. Okay. Yeah, that's pretty sweet. So let me turn it this way. And why don't we... like I should try to... I don't know, just make a whole new one. Yeah, I'm gonna make another new one. And then what I'm gonna do is just try to make the code to make 3 tabs that take up 1/3 of the screen each. And I'll probably honestly call it a night after that. Really what I'm trying to do tonight is get this ready to be used inside the tab layout. Hopefully tomorrow night during the deep dive, I want to work on that. I feel like I'm pretty close. So let's go ahead. We should make one a different size to make sure that there's not something magical about the size, other than the fact that it's divisible by 3. That's making it work. Actually, because you can have different tile widths and tile heights, I think you can actually maybe achieve your 4x3 thing. Because you could, look back at the code. Am I crazy? Is you could tell it, now that we have a way to tell it, the tile size. Yeah. So you could actually make it, you could make it 4x3, and what you would end up with is tiles being wider than they are tall. Your tiles would no longer be square. But they would still repeat, basically the BC from your example would become just B, but B would contain twice as much width as A and C, visually twice as much width. I think you might be able to achieve the same thing, actually, even if we don't change the duplication zone, because in effect, you kind of can affect the duplication zone in a way by passing it a different tile size like this. Let's try one like that. Let's see if I'm actually thinking this through correctly. So let's go, instead of 16, let's use 24. So let's go 24x3 tall, and then 24x4 wide. I don't know off the top of my head. 24x3, 72, 24 by... do we want to do 5? No, let's do 4 first. Just bump it by 1 first. So 72 by 96. It's actually getting fairly large, but that's... well, I mean, still the tiles are 24. That's still pretty small. 72, well, and we want to go actually this way, 96 by 72. And I'll do transparency. Okay, so eyedropper my pink, since the pink makes a good transparency color. I wish the bucket had its own thing, wasn't tied together with the gradient. And I think, how did I actually do this the other day? I think I did something like, this. Select the whole thing, shrink it. Say, yeah, we'll shrink it by 4. That brings it inside. So now we fill this with the color we want our outline to be. So let's say this time maybe we want a blue outline. This. Fill it. Oh, but let's go undo. Let's go rounded already. Let's do a rounded. Rounded. Oh, right. This is this weird percentage. I have no idea what this percentage represents. Percent? 50% of the height and the width or something? No. Seems pretty rounded though. Good to me. It's such a weird thing. I feel like that used to be in pixels, and I don't really know what they mean when they say percent. So let's go shrink now. And let's make this thicker. I think this was 4 pixels on the last one. Let's make it like, let's make it twice as thick, 8. So we go shrink by 8. And this part we'll fill in our gray. And then I think what I'll do is let's go merge this down. Selector. Select this. Let's make it fit here. I don't think it will matter, but we might as well. Copy paste. Layer. Here. And let's try to work in a way that we know the duplication is working how we expect. So basically, let's draw some other stuff on this. Stuff is not going to make a whole lot of sense, but really I'm just trying to get something that we'll be able to look for as it draws. So the way this one is going to end up working is our tile size is going to be 24 tall by 96/3, 32 wide. (32 by 24). This will be our tile size. So in the middle, say 32. Let's go like this. Dot. Then a fairly big space and another dot, and then over here let's do dot dot dot. It's gonna bug me that the middle one is not centered. Does not matter even in the slightest, but it's still gonna bug me. Also gonna make these one taller just because this is probably gonna be small on the screen. And again, this doesn't make a whole lot of practical sense, but this will tell us if our duplication is working correctly. and this basically represents like your B and C from before. If your B and C were different tiles, in this case different because one has 2 lines and one has 3 lines, and I think it should duplicate, I'm imagining. So let's save this. Go ahead and just bump this to 4. Eventually I'll start making names for these that aren't just basically increments. And let's go ahead and start a new CodePy. This one, TileGrid Inflator Simple Test. So this one I'm gonna not do any, I'm not gonna do as many of these. I mean, I'm still gonna do 3, but I'm gonna do 3 of the same size. Let's try, well, okay, so the size is, we want, this does get tricky, doesn't it? We want the, oh, you know what I forgot to do is make this indexed. Check to make sure pink is at 0. Oh, bunch of pinks now. Uh-oh. Well, hopefully... So we don't really want that many pinks. Why did we end up with that many pinks? I guess it's just because... So I guess here is the use case right here. I talked about there being a use case for multiple color indexes, multiple color transparencies. One thing, we're gonna have to merge this. And I guess here it is. So why don't we move all the pinks to the front, and then we'll just keep note of how many there are. I'm gonna try it like this. We'll see how these purples end up. If they're looking really pink compared to the rest of this, then I may come back and remove those also. Oh my goodness, what just happened? What? Why would that happen? Huh. There must be like, maybe if I drop it on another tile, it does a different action that I'm unaware of or something? Yeah, like overwrote one of my blues with pink. Here, this is pretty much what I want this time though. I have no idea why it got all crazy before. Try it like this. All right, so we're actually doing 4. And so basically what we want is the largest multiple of 32 that fits inside of 1/3 of our screen. for the width. So display.width divided by 3, and then that number divided by 32. And for height, we could just, let's say 2 for now. I think this will give us the 1/3 of the screen, or it will give us the like biggest size that is smaller than 1/3 of the screen. I think that's what it should do. I'm actually going to call them tab 1, tab 2, and tab 3. And the first one can be in the top left, so you can just leave it there. Oh, you know what oh. Whoops. Okay, so I just overwrote in this one. So let's do this again, actually. Let's do... And then the other thing actually that I wanted to do is rotate the display. And I do think I saw pink. Oops. Yeah. Actually. Wow. You know what's crazy is the pink comes through the camera a lot more than it does to the naked eye. Especially that top right corner there. Looks very pink through the camera. It also turns out that our center did not end up duplicating more than once. Let's try this at a bigger size to start with. Oh yeah, it's still running. Let's just hard code it to... So something bigger than 3. Just try 6. Yeah. Yeah, so we ended up with basically duplicating that BC, BC, BC over and over again. We just collapsed the idea of BC down into only B. But it does actually, I do think you can make all of the same stuff with it. You just have to, it gets weirder, I guess, because you have to kind of code like this. You have to know the tile size, and then, I mean, I'm also caring about the display width here, but you would always have to do this like magic number tile size here. Oh, hold on. Oh, right. No, yeah. Hold on. Well, yeah, okay, so our default, our default was always divide by 3, and since we gave it a thing that was not square, yeah, we should have ended, let me print out, let me make sure we actually ended up at the right tile size. It does look right to me, so I think we probably did. We get 32 by 24, perfect, okay. It does do that. So that's actually, it is actually nice because you don't have to specify it, but it does get weird because, well, no. Did I not? I didn't, actually. Yeah, no, you don't. You basically, the thing you have to keep in mind is just always go bigger than 3. It figures out the rest for you. In this case, because I'm trying to fit a percentage of the screen, I have to care about the width a little bit more. In the general case, though, where you just make it a size, kind of eyeball it. And so we did 6, which means we got 4 repetitions in the middle. So we have the 2-pack and the 3-pack, and then again and again and again, 4 times total. Nice. Okay. I am going to cut out some more of the pinks. Oh, actually, you know, the thing is, I never did, that's why we still have so many pinks. I rearranged them, but it's still only hiding 0. We should hide all the way up to, which this will give us a chance to test the multiple transparents. We should hide 0 through 7. I can just pass it range. Range 0 through 7. Oh, range 7. No, range 8? Range 8, probably. That's how range works. Yeah. So I don't know if I can actually pass it like that, though. Huh. Yeah, I think it's not a tuple. Range is like its own thing. Can you pass it to tuple? Can. That's probably what I need to do. Yeah, that's much better. There is still a little bit of pink. For some reason, the right edge looks more pink to me than the left edge. I don't really see any pink pixels on the left, but I do see them on the right. Oh, wow. It is still the same, though. Like, I basically cannot see them at all to the naked eye. But I see them really well in the camera. That is bizarre, actually. It's really weird. I don't think I've ever seen something like that with this camera, where it like shows up so much better like that. I mean, they're like clearly pink pixels there, but to the naked eye, I just cannot see them. Are we still? Well, now we're zoomed in. So weird. It's like something to do with being next to the black. Throws off the eye some. Okay, anyway. Strange visual phenomena aside, this does work. It does expand how I was thinking. So let's go and make 3 at 1/3 the size, and then I'll probably call it a night after that. I think this definitely gets me far enough to know that this proof of concept should work for use in the tab layout. So the size will be the same. We will just go we could do more math to take into account the margins and actually make them centered. For right now, I'm not going to mess with it, though. They'll be like slightly shifted to the left. They won't really be centered. Could figure out the margins and center them if we wanted to, though. 3, but then times 2. Oh. Now I control C it accidentally. Yeah. Nice. And these ones didn't actually bring over this part. So this also proves that our multiple transparency indexes are working. Oh, I only copied it once. Or twice, rather. I missed the first one. That proves it even more, because definitely the first one had way more pink. That is so weird that I can't see those. It's also weird that there's... Even when they do appear on the camera, the right ones appear vividly than the left ones. I would have assumed that this was, like, equal. Somehow being on the right or the left of the blue is, like, causing it to jump out more or less. Really appreciating watching you design this stuff. It's helping solidify my understanding of how display works. Awesome. I don't understand as well, but I like as I'd like yet. Awesome, yeah. I'm super glad to hear that. That's definitely a big part of my motivation for streaming this kind of stuff, is letting folks see how I approach problems, and letting folks kind of get a more of a decent idea of how these components work together, or how they can work together. Because there's lots of different ways to achieve different things, but this is kind of the way that my brain works with the components that we have, namely TileGrid and group bitmap. All right, I am gonna, this is pretty much gives me everything I want, but I think one more thing I will do is hide a few more of the pinks, because those extra colors are wigging me out a bit. I think I'll keep 12. 12 is close enough to purple. But all three of these, I think I'll get rid of. Oh, okay, yeah. No, we don't have to change modes. We're already in this mode. So I do need to know the count again, though. This screen is weird because the numbers don't update until you close it. So now we are up to 10, so we want range 11. We do have to export a new one, since I could overwrite, though. It's fine to overwrite. It's the same image. It contains the same data in the image, the same visual data. They just changed around some of the index colors. So I can copy it. Back in there. Right. And then let's go range 11. Oh. It's one of my goals in my streaming too. Nice, yeah. I like that about the CircuitPython community. Folks are very interested in helping others learn. Oh, why are we not saving? Save? There we go. Okay, I don't know why it didn't work. There's still, like... Did I do it on all of them? I did. Maybe I should have done the purple. It's way better now. I really only see like 2 pixels now. And I'm betting it is the purples. Okay. One more try. Doesn't even matter, but for whatever reason, these pixels are weirding me out some. That should definitely do it. This is way more blue than purple. 15 is the only one I'd say that still has pink in it, to any degree. So if I still see pixels after this, then I'm just gonna live with them. I like that it supports this, though, actually. I hadn't even actually initially thought of a use case quite like this, where because GIMP is raster graphics, my corners ended up having so many shades of pink. But this is perfect for that, because you can still cut it out. You know, the other thing that we actually, oh, you know what I did wrong? I think I merged too early. If I would not have if I would have drawn the blue on a layer by itself, would we have still, I guess we would have still ended up with pinks, different shades of pink. I don't know why this wasn't a problem with the first one I did. I guess just because it has super hard cut edges. I don't know how I made those so hard cut. But that's, yeah, that's definitely why it's like that. Okay. So yeah, different layers wouldn't matter. Making these edges hard cut, that's what would matter. Not having the, is that dithering? I don't know if that's actually called dithering. Anti-aliasing? Part where it's like in between colors and it's part of one, sort of, in transparency. So we bumped it up by 1, is that right? We want 12 now? Yeah. I don't know if I copied this, so I'm gonna do this over one more time just to make sure. Yep, overwrite. Code, we're gonna do 12. Former boss of mine used to say, a rising tide lifts all boats. Yeah, it's a very good philosophy, I think. Nice, okay. Yeah, now I don't see the pink at all. It also doesn't help that my screen is dirty. Well, my screen protector is dirty because I don't take screen protectors off until I absolutely have to. But yeah, I definitely don't see the pixels anymore. So yeah, this would be perfect for tabs. I will, as part of the tab layout, probably figure out the extra margins. Pretty much what we need to do is find the parts that this and this are rounding off, and then scoot over a little bit based on that amount that's getting rounded off. And then we should be able to center these up to where the center one is exactly in the middle, and then they each have the same amount of space around them. Or I think that we still end up with more space between these two than we do between the first one and the edge and the last one and the edge. I think we end up with a half space between the walls and a double size twice as wide as that half space between the actual tabs. This is reminding me of CSS that I just taught a couple weeks ago. There's a thing inside of table, grid layout for display grid inside CSS, where you basically declare this exact same concept of you want the double size or the half size space on the edges. Okay. All right, I think that's going to do it for tonight. So I should be able to take this tomorrow, and I'll probably still make a couple more examples of the sprite sheets, and then I'll utilize this within the tab layout to allow you to draw these backgrounds as the tabs. Maybe I'll make one with a square top right corner as well, just to show that you really do have control over a lot of how this thing looks. By changing the sprite sheet around, you can get a lot of different effects. And then I'll put the text inside of here for each tab. And we'll work on touch events or something else if we get all of that done. So that's what I'll be doing, I think, tomorrow on Deep Dive. Thank you to Tammy. Thank you to everybody else who is watching. Folks, if you don't follow Tammy on Twitch, head over to twitch.tv/TammyMakesThings. She streams as well, working on similar types of stuff on CircuitPython. So that's a good stream. Head over there. And yeah, I'll be back tomorrow night. So I'll see you all then. Yep. Thank you.